Hello everyone, this is going to be a video on how to match piecewise functions to the graph, graphing piecewise functions, identifying piecewise functions from a graph that's already graphed, like these right here. We're going to jump right into it. The directions say match the piecewise function to the graph. So that's what we're going to do. We're going to take a look at, and there's a couple of things that I do that will kind of make it easier for you, and it makes it easy for me. I identify the lines that have that are horizontal, and they have a zero slope. So I know they're like y equals a certain number. Remember, a zero slope is a horizontal line. So I'm keying on this part right here, and this line, right? So that line is what I'm looking at right now. I know that this line crosses that y-axis at -1, -2, -3. So all along this line, I know that this is y equals -3. If I grab my calculator and I say, all right, I don't know what I want to just make sure that what y equals -3 looks like, I could just put that directly into the calculator and graph it, and that's the line. But they just want a piece of that line. So what happens is that you're going to go, okay, it has to say y equals -3. See this f of x? That's just like the y. That is the y, f of x. Y equals -x? No. Y equals x? No. Y equals -3. Y equals 4. Y equals this. Y equals 5. Y equals -3. There it is right here. X is less than or equal to 1. So here's the 1 on that x-axis. Less than is in that direction right there. B is this right here. I'm not even checking the other one because I'm identifying the horizontal line first. It's the easiest to identify. So I'm going to erase this, and that is B. You could see 2x plus y equals 2x plus 1. This would cross the y-axis right about here if you continue that line. So that's 2. It's a rise of 2, a run of 1, rise of 2, run of 1. That's a slope of 2. It starts at 1, so that's why its x is greater than 1. So that's B. 2 I'm skipping. 3, here's that horizontal line. I'm going to stop right there. I'm going to continue this horizontal line right here because I want to see what that y-intercept is. I'm going to count up 1, 2, 3, 4, 5. So this is most likely y equals 5. So I have a y equals 5 right here. Do I have another y equals 5? Nope. So E has to be your answer for 3. Remember, it starts at -3. That's the domain. And it continues on in this direction, less than. So x is less than 3. And you see that has an open circle right there. That open circle. That means it's not less than or equal to. It's just less than. Right? It doesn't include that point. It's just less than the -3. So I have 2. And so I could cross off E. I could cancel out E. I used E, and I used B. So here we go down here. There's another line here that's horizontal, and I am going to look at this right here and continue it from there to here. And I'm going to count 1, 2, 3, 4. This is y equals 4. So that line is y equals 4, and the domain should be, this is 2, the domain, the x is 2, and greater than 2, greater than or equal to 2, because that's a closed circle. So if I'm going to go y equals 4, there's one that says y equals 4, it is C, and yes, it says x is greater than or equal to 2, so this one here is C. So I really didn't look at the other lines. I mean, when you have a matching game like this, it's kind of easy to see what what the horizontal line equals. So let's just take number 2 for example, where we have the one thing that this has in common. First off, I don't know what this is yet, but it does have a y-intercept of 0. So you have two lines with a y-intercept of 0. So just take a look. This y-intercept is 1, right? And first of all, B we already used C. This y-intercept is -1. This y-intercept is -1. This y-intercept is -3. The only two with a y-intercept of 0 is A. Y equals -x. -x is this part right here. Let me highlight that for you. That's -x, which is right here. And that -x has to be x is less than 0. Less than 0 is going in this direction here, less than 0. Then you have y equals x that's greater than or equal to 0, and that's the green section. So that this is the green, and this one is the y equals -x. And that is A. So now we have it down. This canceled, everything's canceled. D is the only one left. So we're going to just save that right here. Looking at the y-intercept, you see this is the y-intercept of this one, and actually it would be the y-intercept of the other one as well. That's the -1 that I'm looking at, and -1, that's your D. And that's how you do those. Right? When it's multiple choice, it's a lot easier to deal with, and you kind of use what the graph tells you. Look at the horizontal lines first. The horizontal lines are the easiest to identify, right? Remember, it has a slope of 0, so if you see y equals 5, so obviously it has to have a y-intercept of 5, and the line has to be horizontal just like this. And that's it. So remember that this is your y. The whole f of x is like y. And it equals, there's two equations here. There's two functions. Y equals, f of x equals x plus 5 for a domain of x is less than -2. And f of x equals -4 for when the domain is x is greater than or equal to -2. So let's just talk about and focus in on this part right here. Inside the parentheses is just like them giving you what x is equal to. They want you to substitute 3 inside the 3 in for the x. All right? So, but the thing is, 3 can only fit into satisfy one of these domains. So it's 3, right? Is 3 less than -2? No, it's not. So you're not going to fit it into this function. You're not going to substitute it into this function. x3 is greater than or equal to -2, so it actually fits into this function. That function is just -4. Y equals -4. So that means no matter what the x is, when x is greater than or equal to -2, y is going to equal 4. So this is 4. It's kind of like, okay, I'm going to put the x in as 3. They're giving you the x as 3, but the y is always -4. Sorry, it's -4. So that would be the coordinate. Doesn't matter what the x is, as long as it satisfies the domain, x is greater than or equal to -2, and 3 is greater than or equal to -2. The y is equal to -4. So let's go over here. This is your x, this -4. Is -4 less than -2, or is -4 greater than or equal to -2? X, f of -4 is less than -2. So we're going to use this first function here. So we're going to put, instead of the x, we're going to put -4 plus 5. -4 plus 5 equals 1. So when the x is -4, the y is 1. So you would have in there -4 as your x, and when x is -4, the y is 1. It's a coordinate. They're not asking for the coordinates. The answer is this right here. Right? This right here. I'm just giving you the coordinates to kind of make sense of it. Whatever's inside the parentheses, that's your x. So here's your x. And so you have to figure out which domain that x could fit in to satisfy and to figure out which function that you're going to use. So you have -2. Is that greater than or equal to -2, or is -2 less than -2? -2 is greater than or equal to -2. So you're going to use that last one, and that last one is -4. All right, so when x is -2, the y is -4. That would be your coordinate. And let's go on to number 7. Number 7, this is your x, -2. -2 is not greater than or equal to 1. -2 is less than 1. So I'm going to use this function on the top, and I'm going to put 2 times x. Sorry about that. So when you have to substitute in that -2, we're going to substitute that -2 in for x, and then you have +1. And we're going to do 2 times -2 is -4, and -4 plus 1 is -3. And that is your answer. When x is -2, the y is -3. For 6, that's your x, the 6 inside the parentheses. It falls within this domain. 6 is greater than or equal to 1. So I'm going to use that second function, and I'm going to substitute 6 in for the x. This is -12 plus 3. -12 plus 3 is -9. And that is your answer for that. When x is 1, is 1 less than 1? No. 1 is greater than or equal to 1? Yes. So I'm going to use that second function again. Substitute the 1 in for x. And I have -2 times 1 plus 3 is +1. And that is my answer. To go on to number 8, we have -4 is as an x. We have -4. Let's see which domain satisfies that. -4 is less than or equal to 2. So that means it's -2 times -4 minus 4. So we have, you can put this in the calculator. You don't have to do it by hand, or in your head. This is -2 times -4 is +8. +8 minus 4 is 4. And that would be your answer. When x is -4, the y is 4. It's like an input and an output. So x, 8 is 8. I'm going to go, okay, 8 is greater than 2. So I'm going to use this second function. So I'm going to put 4 times 8 minus 9. Now this one I'm going to use my calculator for. 4 times 8 minus 9. And it'll give you that answer right off the bat. It's 23. All right. And then f of -2, remember the +2 is your x. Is 2 greater than 2? No, it's not. 2 is less than or equal to 2. Yes, it is. We're going to use this top function, -2 times 2 minus 4. -2 times 2 is -4. And if you really want to just check the calculator, is negative 2 times 2 minus 4. Grab that calculator, is negative 8. And that's it. All right, just taking a look at graphing itself. Okay, so graphing, you know that you have to just do one at a time. Don't try to take any more than one at a time. So you grab your calculator, and the first thing that I'm going to graph is the f of x equals x, right? So I'm just going to put x in, and I'm going to graph it. And that's what my whole line looks like. That's a y equals x. That's what that is. So slope of 1 and a y-intercept of 0. But they're only concerned with when x is less than or equal to negative 1. So I'm going to press second function and table. And I'm going to go to negative 1. I'm going to go up a little bit further. And I'm going to go back down to negative 1. Negative 1 is where I'm going to start this graph. And it's or equal to. You see, it's or equal to. So I am going to go and see if I could graph this line. So I'm going to start at negative 1. And remember, it says less than or equal to. So I'm going to go negative 1, negative 1. And I'm going to put less than or equal to. I'm going to put a nice, big, giant enclosed circle. Then negative 2, negative 2, negative 2. Right here. Negative 3, negative 3. Right here. Now you know that this slope is 1. So I'm just going to continue just like this. All the way down to negative 10, negative 10. And I do have that on my graph, my graphing calculator. So I'm just going to connect these points, and I'm going to minus this calculator out just to check. Put the arrow on the end there. And I could put f of x equals x, semicolon, x is less than or equal to 1, negative 1. And see how I start at negative 1, and less than would be this way on the domain on the x-axis. All right, let's go ahead and graph the second line. The second line says f of x equals negative x plus 4. So negative x plus 4, we're going to put this out right here. Y, and we're going to clear this. Negative x plus 4. And I did not do that correctly. Negative x plus 4. And press graph. All right, so we have that part as my graph. So the graph looks, all right, okay, so it has to be x is greater than negative 1. Don't start with negative 2. Don't start with negative 2. You're starting with whatever the domain tells you to start at. But it's just greater than. It's not greater than or equal to. So that means it's going to be an open circle. So let me go back to the graph here and press second function and table. And just remember, I have x is greater than negative 1. So x is greater than negative 1. I'm going to go down to negative 1, just a little bit beyond it. So it goes up on the screen. So I have some points. And I'm going to go back to negative 1. Greater than negative 1 is negative 1, 0, 1, 2, 3, 4, all the way greater than negative 1 until I can't fit any more in the graph. So I have to remember that I have to graph x is greater than negative 1. So I'm going to start with negative 1, and it's going to be an open circle. That negative 1, 5. So the negative 1, 5 is 1, 2, 3, 4, 5. This is going to be an open circle. Nice big open circle. And then 0, 4 is right here. Those don't have to be open. 1, 3. The rest of the points are, you're just putting points down. All right, you don't have to open circle it. It's just the end that's the open circle because its x is greater than -1, right? And you're showing that -1 is not included, but you're starting there. It's an open circle. All right, so you're going down. This is a -1 slope, -x. And just like that, just to check, I have 7, -3. So 1, 2, 3, 4, 5, 6, 7, -3. 8, -4 is down there. 9, -5 is down there. I should have that. Let me go down and just check. And then 10, -6. I should end it with 10, -6, and that's there. So let me go ahead and get my ruler out. This is my arrow, and I'm going to put f of x equals -x. That's a -1 slope plus 4. The y-intercept is 4. And semicolon, and I graphed when x is greater than -1 as the domain. When you're focusing on the domain, you're focusing on just the x-axis. That is the domain. So when we're talking about x is greater than -1, this is my -1 right here. Greater than that is this way. That's what you're graphing. And that's it. Number 9 is finished. Number 10 is there's 3 graphs that you have to 3 functions here that you have to graph. All right. So we're going to take this y equals 5. So on my graphing calculator, I'm going to put y equals 5 first. I'm going to clear that out. Press 5, graph. That's the y equals 5. It crosses at 5. So if you want to put like, hey, all right, it crosses at 5. That's 1, 2, 3, 4, 5. You can put a little point here just to help yourself out. All along that horizontal line, that 5, where y equals 5, that's the line. So remember, it's saying that it wants you to graph x is less than -2. So remember what I said about the domain. The domain is only here. Your eyes are right there. So when x is -2, x is -2 is right here. That's -2 as your x. So we're going to open circle this. Nice open circle. And we're going to just put points if we were graphing this whole line, y equals 5, we would continue the points all the way across. But since they only want where x is less than -2, we just want this part. And this is f of x equals 5. Semicolon, x is less than -2. All right, you can even erase this. That's finished. Now we have y equals a half x minus 6. Let me grab the calculator again. Clear that out. Alpha x, 1/2 x minus 6. I think that's what it said. Yes, -6. And we're going to press graph. That is the entire graph. But we don't want the entire line. So we want just the numbers between -2 and 6. -2 and 6 are the two numbers that you're going to circle. They are both or equal to's, so they're both going to be closed circles. All right, so let me grab the second function and go down or up to -2. See where -2 is? That's going to be my first circle. So I'm going to just try to get this all the way over here. And we are going to go to -2, -7. 1, 2, 3, 4, 5, 6, 7. And this is going to be a closed circle. And then we're going to graph all the way until you see 6. X is greater than or equal to -2, and X is less than or equal to 6. So I'm going to go down to 0, -6, because those are two whole numbers. So we have zeros right here. 1, 2, 3, 4, 5, 6. I'm going to put a point there. Then we're going to go down to 2, -5. 2, 1, 2, 3, 4, 5. And then we're going to 4, -4. So 1, 2, 3, 4. 1, 2, 3, 4. And then finally 6, -3. 1, 2, 3, 4, 5, 6. 1, 2, 3. So this line that I'm graphing is x 1/2 x minus 6. And what it does is cross at 6, -6. It's 1/2, so the rise of 1, run of 2. Rise of 1, run of 2. Rise of 1, run of 2 stops at 6. Here is 6 on the x. There's the domain. And here's -2. It starts at -2. -2 and 6. Let's go on to the last one. It's -2x plus 10. Y equals -2x plus 10. It wants it graphed from x is greater than 6. So greater than 6, this way, to the right. So we're not going to fit much on. So we're just going to have to go ahead and graph -2x plus 10. Graph it. Press second function, graph. Since it wants greater than 6, I'm going to go down to 6 and stop there. 6, -2. That is my first point that I am going to graph. It is a greater than symbol, so that means I am just going to put a open circle on 6, -2. Open circle. Then 7, -4. 1, 2, 3, 4. And then 8, -6. 9, -8. And 10, -10. Notice I have my open circle. And put my arrow here. And then put f of x equals -2x plus 10. That y-intercept would be 10. And then it has to be x is greater than 6. And then this one here is f of x equals 1/2 x minus 6. And the compound inequality is x is greater than or equal to -2, and x is less than or equal to 6. And that's it. It's time consuming, but you do one at a time. Take your time, use your calculator. All right. So 11, 12, and 13, write piecewise function for the graph. I am just going to go ahead and figure out this one first. These are going by 2's. So this is 2, this is 4. So I know this is y equals 4. And I know this is f of x, so I'm just going to put 4 here and put the semicolon. And it starts at 0 and it goes on forever. So we have x is less than, and this is a closed circle, or equal to 0. So this is a little tricky right here. This part is an open circle here. All right, that's not the tricky part, but it's in between the 1 and the 2. I'm sorry, the 0 and the 2. So that means I think the y-intercept is 1. So I'm going to put b equals 1. And I'm going to have to figure out the slope. So I'm going to pick points that don't really, this is 3. Like it's not, like we're not sure, but it's right in the middle. So I'm going to say it's 3. And this is 1. So that means I'm going to go over 2. I know that's 2. And then from 1 to 3, that's also 2. So it's a 2 of 2. 2 over 2 is 1. So we have x and then plus 1. And then the domain is from the 0 on to, forever in the other direction. So it's greater than, and it's not greater than or equal to, so it's an open circle. And greater than 0. And that's your graph there. All right, so the function, I'm going to start with this one. So this right here, obviously this is going by ones because it's not saying that it's not going by ones, so I have to say it's going by ones. So if it goes down 1, that's -1. And if it goes to the left 1, that's negative. So this is -1, -1. I am going to go up and continue this line this way. So the y-intercept of this line equals 0. Okay, so the y-intercept is 0, and then this slope is a positive 1 over 1. So we have, if we pick 2 points, it's obviously 1 and 1. So that means it's x. And this is a positive slope, it's going up. So it's 1 over 1. And then plus, it's plus 0. So you just put x. Semicolon, and where they're graphing it is, this is your -1, and it goes on forever in that way. So it's x is less than -1 because you're graphing less than -1. For this graph, this starts at 1 and it goes on forever there. So we're gonna just continue this line. So it's going down 1 and over 2, down 1 and over 2. So if you connect, it has to be right there. So the y-intercept will be a little bit difficult, but it's between 1 and 2. So I'm going to put 1.5 as the b. b equals 1.5. And the rise is 1 and the run is 2. Rise is 1 and the run is 2. So it's a half x plus 1.5 semicolon x. It starts at 1. X is greater than, has a closed circle, greater than or equal to 1. Sorry if that's sloppy, but that's it. We're going to talk about this horizontal line. This is a y equals -2x line, -2 line. So we're going to put -2 right there. That domain is x is less than or equal to -3. See how it starts at -3? This one has 2 open circles. At least I think they are. There's 2 open circles. So it starts at -3 and ends at 0. So the domain, you can actually figure out the domain right now. It's a compound inequality because the 2 numbers are circled. and it is open circled, so we're going to put x is greater than -3 and x is less than 0. I didn't even get the equation yet. So b equals 4, because that's the y-intercept. And then we're just going to pick, this looks like a -1 slope. It's down 1 and over 1. So we have a negative x plus 4. We're going to start at 0 here, and we're going to just continue on forever in that direction. So we could actually put together the domain first. X is greater than or equal to, because they have a closed circle, and it is 0 is where it starts. This does look like a rise of 1 and a run of 1, so that means it's just x. And let me get that out of the way, if I can. And that's it. Right, and that was number 13. Number 14, again, we have, talk about a horizontal line. I like the horizontal lines because I know that this is y equals 3. All along these lines, if you ever get confused, just kind of put points all along the line, and you could see that every single time a coordinate has y equals 3, where it crosses the y-axis, it's 3, so it's y equals 3. So I'm going to put that down right off the bat. Then I'm going to put semicolon, and I know that the domain is 0. All right, it starts at 0. So x is, and it goes less than or equal to because it's the closed circle, and you have 0 there. For this one, the y-intercept is -2, so I'm going to put b equals -2. And I know that this is a slope of 1 because it's a rise and run of 1. So that means the slope is x, just 1x, plus, I'm sorry, -2 for the y-intercept. You could put the domain down, and the domain is 0, goes on forever in that direction, the greater than direction. And it's just greater than, not greater than or equal to, because it's an open circle. Those are your two functions, and let's go on to number 15. Number 15 has a y-intercept of 4. And I'm just writing on the graphs. And this right here is where I would just go ahead and use this and this. Be careful, these are going by 2s. All right, so this would be 6, this would be 8. All right, 2, 4, 6, 8. Who do we appreciate? And then this one goes by 2 as well. All right, so if this is going down, see 8, 6, 4, that's a -4. -4 over 2. -4 over 2, the slope of that little line there, the slope of that line is -2x. -2. And you just put the x in because we're just putting it together for the equation. The y-intercept is 4, so we're going to put +4. All right. So now your domain would be 0 and less than. All right, so x is less than or equal to 0. It's or equal to because that is a closed circle. Here's an open circle. If you want to do the domain first, you could say 0 and greater. All right, greater. All right, not the line itself, but just the x-axis, like that. Greater, and it's not greater than or equal to because this is the open circle, so it's going greater than in this direction, greater than 0. So let's go see what this slope would be. I'm going to pick 2 points, and let's go. So this is 2, and this is 2, 4, 6. 6 divided by 2 is 3. So it's 3x, and then it's 3x because it's the y-intercept is 0. So that's your second function. And that is that. Okay, so we are going to graph. This is number 16. We're going to graph the piecewise functions here, and then we're going to evaluate for -4. We could use, I'll show you how to use the graph, and I'll also show you how to use each function itself. So let's go ahead and graph y equals 2x minus 1. So I'm going to grab my calculator, y equals 2x minus 1, and put that in. You notice that my line should look like that, a full line, y equals 2x minus 1. They only want me to be concerned with x is less than or equal to -2. So I'm going to press the second function in graph. It has to be less than or equal to -2. I'm going to go down a little bit, and then I'll go right there to -2. That is my first point, and my first point, since it's less than or equal to, has to be a closed circle. So it's -2, -5. 1, 2, 3, 4, 5. And that is a closed circle. Then it's less than, right? Less than -2. So -3, -7. 1, 2, 3, 4, 5, 6, 7. And then -4, -9. And then you can't fit any more. So I'm going to connect those those points just like this. And put an arrow there. So this is f of x equals 2x minus 1. And that is a domain of x is less than or equal to -2. Let's go ahead and graph y equals 4. So I'm going to just jump up 1, 2, 3, 4. That's my y-intercept. It has to be in between the, I'm going to do this all without the graph, without the graphing calculator. It has to be in between these two numbers as the domain. So I am going to go to the x of -2, and right here is -2. So I'm going to stop there. So I'm just going to erase that, and it says x is greater than -2, and just put an open circle. Then I'm going to go all the way to where x is 3, and I'm going to put a closed circle because it's or equal to. So this is -2, this is 3. This is the line y equals 4 in between the -2 and the 3. And that's my line. So this is f of x equals 4. And with the domain of -2, x is greater than -2, x is less than or equal to 3. And then one more line right here. I'm just going to get rid of these for now. -x plus 2. Going to clear this out. There's my line, y equals -x plus 2. So the -x plus 2, they want it just for when x is greater than 3. So I'm going to press second function table, and I'm going to go down to 3, go past it a little bit, and go back up. 3, -1. So 3, -1 is right here. But let me just check to see if that's an open. It's an open circle because it's or equal to. So 3, -1 is a nice big giant open circle. 4, -2. 5, -3. 6, -4, and just keep on going like that. This is f of x equals negative x, that's the negative slope, plus 2. And x is greater than 3. That's the domain. All right, when it says evaluate, you could use, like I said, you could use anything at your disposal. I'm going to use the functions at some points, and I'm going to use the graph at another point. Remember, this is your x. So when x is negative 4, what's the y? So when x is negative 4, 1, 2, 3, 4. When x is negative 4, the y is 1, 2, 3, 4, 5, 6, 7, 8, negative 9. Negative 9. Now, if I went to use the functions themselves, you see this negative 4? It has to fit into one of these domains, and it fits into this one. Negative 4 is less than or equal to negative 2. So the way you would do that is 2 times negative 4 minus 1. And negative 2 times negative 4 is negative 8 minus 1 is negative 9. You see how we got the same answer? This is using the graph. This is actually using the function. The function equation. So when x is 3, what's the y? When x is 3, the y is, don't go down there. That's the open circle. So that means it does not include when x is 3. Go up here. So when x is 3, the y is 1, 2, 3, 4. Let's just go see where it fits in. Look, here it is. It fits in right here, but doesn't fit in here. So x is less than, when 3 is less than or equal to 3, that means that y is 4, so it's 4. When x is 8, what's the y? So I'm going to go over to 8. 1. I'm going to go straight over to 8. The y is 1, 2, 3, 4, 5, 6. Negative 6. And 8 would fall right into this one. So if you're using the function equation, you would go negative 8 plus 2 is negative 6. Either way, you could use the graph and the function. It should come out to be the same, get the same answer. Just remember, inside parentheses, that's the x, that's the input. And they're asking for what the output would be when that x is that, right? And that is it. Okay, any questions, just be sure to ask. And I hope that helped, that video. And thank you for watching, and I'll see you next time.